Hi, in this short video, I will talk about software lifecycle. I will talk about the input, activity, and the output of each step in the software development lifecycle. There are 5 steps in the waterfall process. They are requirements, analysis and design, implementation, testing, and maintenance. Each step produces an output. The output can be document or production code. In the requirement could be functional. For example, what the software should do, on input X produce Y, or non-functional, criteria against which the system is measured. For example, when users submit the data, the system should respond within 2 seconds or less. Here's a requirement. Design a program that lets user enters the total rainfall for each of 12 months into an array. The program should calculate and display the total rainfall for the year, the average monthly rainfall, and the month with the highest and lowest amount. Given this requirement, what are you going to do? Well, you should sit down and analyze and design the program. Determine the architecture, the system architecture, the software architecture. Determine what is done in the software. And at this stage, you are creating an abstract model. It can be high level and a low level design model. This stage, generally speaking, we are doing what the software should do, not how the software is done. The next stage is the implementation. In this stage, you translate the design into code. This is when you develop the algorithm, object, function, control structures. This is the stage where you actually write the code. After you write the code, how do you know the code is working? Then come to testing. You have to test the code, and testing can validate the code in 2 ways: that it does what it should do. It can have functional requirement and non-functional requirement. And it also validates that it doesn't do what it shouldn't do. For example, a graceful failure. If the invalid input, graceful failure or error recovery when invalid input is entered, or when certain problem happen. This is a lot of time. This could be the problem. These tests wasn't the failure case wasn't tested thoroughly, and the program did not do what it's supposed to do. What happened when the program didn't do what it's supposed to do? After your product go out, well, you have to maintain your program. It's an ongoing development to fix bugs, add new features. It can be more than 80% of man-hour. Why? Take a look at Windows 7. Windows 7 just got end of life, but Windows 7 came out, I believe, in 2009. It's been 10 years. And it's been in maintenance mode for 10 years. Windows 10, same thing, is in the maintenance mode. Every 6 months or so, they have a new release or new build which fix bugs and also add new features. That typically separate the academic project from production. What I mean from that is, when you do assignment, typically you don't add more feature to your assignment. You could if you want, but you don't have to. Waterfall process have many advantages. It's simple, easy to benchmark, and clearly delineated milestone. If you're a project manager, you will like the waterfall process because you know what happened in each step, how long each step gonna take, and you know when you fall behind. But waterfall process also have problem. Assumption stable requirement, stable technology or staffing, early risk identification, familiar with the problem domain, no need for feedback in the system. Well, early mistake could be costly. For example, in the middle of testing, you find a problem, and you find a problem in the requirement. And then what's going to happen then? You go back and change the requirement, and everything start over again. And that could be take time, and time is costly. In the spiral process, instead of we still have the 5 step: requirement, analysis and design, implementation, testing, and development. But instead of doing each step one by one, we are doing more like a iterative approach. We're doing it in a smaller project, smaller team, shorter development time, more user involved. This is what we call incremental software delivery. Instead of deliver something big, which take maybe 1 or 2 years to develop, deliver something small, which might take 3 months, 3 to 6 months, or even shorter to develop. This is for and the example would be agile software development or extreme programming. These are the terms that you might have heard before. Advantages: changing requirement, because smaller set of requirement, changing requirement is not as critical. Early problem discovery, always working software because we're only doing little by little. Extended feedback because we have a user, like an end user feedback. The main problem would be architecture. What happens if you find a problem with the architecture down the road and you have to re-architect the software? Here is how our assignment map to the software development lifecycle. Requirement, like a homework or lab problem. Analysis and design, you will think about how to approach and solve the problem. Create an algorithm, that typically the step when you do the analysis and design. Implementation, write the code. And testing, test the code to make sure all functions work properly. Don't skip that. And maintenance, well, you can make your code look better, or you can make your code look add more feature to your code, but this, generally speaking, for homework is not needed. As long as your homework work per the requirement, you are good.